let's discuss Kendall coefficient of concordance W. So Kendall's W statistic, sometimes called the coefficient of concordance, is a non-parametric statistic used to assess agreement between different raters and ranges from 0 to 1. 0 is no agreement at all between raters, while 1 is a perfect agreement. The statistic is calculated either on an interval scale or on an ordinal scale. For example, let's say a group of workers were asked to rank a list of workplace concerns from the least important to most important. If the W statistic is 0, that means everyone ranked the list differently or randomly. If the W statistic is 1, then everyone ranked the list is exactly the same order. But we have to be cautioned. You should only use the W statistic for measuring concordance between variables that are measuring the same general properties of objects. For example, if negative and positive correlation are of equal importance, this would not be a suitable test. The concordance is the notation. Okay, the notation of the concordance. This would be uh, the notion when the uh, if the statistic is from a population. So this is from population, and we have W bar if the notion, okay, for the uh, sample statistic. Okay, so hypothesis, H sub 0 or the null hypothesis, there is no agreement among the raters, and the alternative hypothesis, there is agreement among the raters. So according to Legendre, the term judges is usually used uh, in the social sciences. But Kendall's W isn't restricted to situation in the social sciences where people rank a list of items. For example, judge or the judges could be species where the population size can be used to evaluate the habitat quality and then the characteristic of different species, individuals or populations, which is deals in the taxonomy. Okay. So for example, seven judges rank order the same eight movies in the results. The average rank is used in cases of ties. Okay, calculate the Kendall's W for this data and the test where there is no agreement among the judges. Now for our null hypothesis here, we could have H sub 0, okay, there is no agreement among the judges. And for the alternative hypothesis, okay, there is agreement among the judges. Okay, so how we are going to use the megastat in doing this kind of problem? To do that, okay, we are going to click the add-ins, megastat, and then we go to non-parametric test, and then we choose the Kendall coefficient of concordance, and then we highlight those numbers, and then we have this correct for types. Okay, and click OK. So here we can see here that you have the sum of the ranks and the average rank of a movie A, and then movie B, movie C up to movie H. Okay. Here we can see here that there are seven. Okay. There are seven, and the chi-square for the corrected for ties is 31.657 with a degrees of freedom of 7. Okay, so here we have seven judges, and then there are eight movies. Then you have the degrees of freedom is n minus 1, so you have 7. So the p-value here is less than 0.05. So this means that we are going to reject the null hypothesis. So if we go back to our PowerPoint, here there is no agreement among the judges. So it means here that since we reject the null hypothesis, this means here that the judges has unanimous decision. Although as you can see here that the judges okay have different ratings per movie, but statistically speaking, we could say that the judges have agreement among the with themselves to have this to in which this means that the whatever their their ratings, the ranks in the movie, they're statistically the same. Okay.